Welcome students. Today we will start electrostatic. So what is the meaning of electrostatic? The study of electron in rest. Electron in static position. Electron in rest. So what is charge? It is an intrinsic property of a particle due to which electrostatic or electric, magnetic and or electromagnetic phenomenon occurs is known as charge. So let us go to the point, come to the point. Lots of properties we cover, that is additive in nature. So what is additive in nature? If I am telling there is a particle where Q1 charge is there, Q2 charge is there, Q3 charge is there. So what is the net charge? Q1 plus Q2 plus Q3. And second part is quantization of charge. What is quantization of charge? Q equal to NE. The charge can be represented as integral multiple of E. So what is E? E value is 1.6 into 10 to the power minus 19. Charge of electron. Charge of electron is 1e, that is a negative sign, minus 1.6 into 10 to the power minus 19 coulomb. So from here, one interesting phenomenon is there. 1 coulomb equal to this number of electrons. So how many electrons will give you 1 coulomb charge? Very simple thing. 1 electron equal to 1.6 into 10 to the power minus 19 coulomb. So 1 coulomb equal to 1 by 1.6 into 10 to the power minus 19 number of electrons. That is nothing but, if you solve it, we will get 6.25 into 10 to the power 18. If you solve exactly, we will get, after solving this, 6.25. You just calculate it. For the timing, maybe right or wrong, you just solve it. You will get, I have 6.25 into 10 to the power 18 number of electrons. Please check it. Now the question is, based on this, lots of questions can be asked. This is one of the question. Number 1. Question number 2 can be asked. For example, I am asking you, suppose 100 gram water contains how many electrons? My question is, 100 gram H2O has how many number of electrons? How to solve these things? First, let us think it. 100 gram H2O. So how many? For these types of questions, we need to apply a formula, Avogadro's number concept. In that concept, we have to apply that this is a molecule. Molecule means, by the help of mole concept, we will write Avogadro's number by molecular weight into mass is number of molecules present in a molecule case. For elementary case, atoms. Okay, we will see it. So first question is, one molecule of H2O, how many electrons are there? Or we'll see how many atoms are there. 8 oxygen, 2 hydrogen, that means 2. So what I am telling that 10 number of electrons are there. How? Let us check it. 1 hydrogen atom. Here 2 hydrogen atoms are there. 1 hydrogen atom contains 1 electron. 2 hydrogen atom means 2 into 1, 2. 1 oxygen contains 8 electron. So it is 8 plus 2 is 10. Now my question is, what is the molecular weight? If I'll calculate, for hydrogen 1 plus 1, 2. For oxygen 16. So we are getting 18 is the molecular weight. What is the formula? Total number of molecules. So number of molecules in 100 gram water. What is the formula? Avogadro's number by molecular weight into what is the weight given or the mass given, that is 100 gram. So if I apply that formula, I will get, let us apply it here, Avogadro's number 6.023 into 10 to the power 23 divided by molecular weight, we got it here 18. What is the gram given? 100 grams. So this number of molecules are there in 100 gram of water. Now my question is, so one molecule contains 10 number of electrons. So this amount of molecule will contain, so now I will write number of electrons present in 100 gram H2O. So what is that? Let us check it here. So how many molecules are there? 6.023 into 10 to the power 23 by molecular weight into mass 100. But one molecule equal to 10. So into 10. So after solving this, I will get 3.35 into 10 to the power 25 number of electrons. So if anybody will ask how many negative charges are there, how many positive charges are there, for that case you have to multiply 1.6 into 10 to the power minus 19. Okay, let's go for the next part, the most interesting part, Coulomb's law. So what is the Coulomb's law? Let us remind. Coulomb's law case, we will get like Newton's law of gravitational force case. It is the product of the masses and inversely proportional to the square of the distance. Similarly, Coulomb's law is also there. So let us consider here two charged particles are there. Let this is charged particle A having charge Q1. Let this is another charged particle B having charge Q2, and they are separated by a distance R. So what will I write? Coulomb's law formula. Let us apply it directly. It is telling that the force of attraction or repulsions between two charged particles is directly proportional to the product of their charges, inversely proportional to the square of the distance, and acts along the direction of the line joining between them. So this part is vector part, the last part, we'll discuss it later. Let us go for the scalar part first. So what I got here, combinedly, this is Q1, Q2 by R square, or if I will remove that proportionality constant, I will get K, Q1, Q2 by R square. Now, this is scalar form of Coulomb's law. Vector form, we'll discuss it later. So let us go for that Coulomb's constant K. So who is that K? This is electrostatic force constant or Coulomb's constant, you can tell. You can tell it's Coulomb's constant also. And if it is for free space, I will write it here 1 by, if it is in air medium, I will write 1 by 4 pi epsilon naught. And this value is equal to 9 into 10 to the power 9. Epsilon naught value is 8.85 into 10 to the power minus 12. Now let us check these units properly. So if I'll take K this side, if I'll take R square this side, Q1, Q2 this side, so Newton meter square by Coulomb square. This is Newton meter square by Coulomb square. This is inverse. So what should be the formula? The unit will be Coulomb square, Newton inverse, meter inverse square. So if I'll go for, if I'll put this value, similarly I will get the dimension of this vector. So what is the dimension of epsilon naught? If I put all these things properly, I will get m minus 1, L minus 3, T4, A square. If you will derive it, you will get it. So what is that epsilon naught? It is known as absolute permittivity. In free space, or permittivity in free space. It is a property of a medium. Just for the timing, you just catch it. This is the degree of penetration of the electric field inside a material. It measures. Okay, we'll see these things later. For the time being, epsilon naught value we need to remind. No need to remind this value. We need to remind only K value is 9 into 10 to the power 9. So this is the Coulomb's law in scalar form. For example, if I will tell, let 10 coulomb charge, actually 10 coulomb charge is a very big charge. Okay, for example, I am writing, let's here 5 coulomb charge separated by 1 millimeter distance. Let this is A, this is B, or I can write this is first charge, this is second charge. Obviously, force acting on each other are equal. Force acting on 1 due to 2 means force acting on 2 due to 1. F is 1, 2 or F to 1. These are in scalar form. Force acting on 2 due to 1 is F to 1. Force acting on 1 due to 2 is for F1, 2. Both are magnitudes are equal. Directions we'll see it later. That is equal to K into Q1 into Q2 by R square. What is K value? 9 into 10 to the power 9. Q1 is 10. Q2 is 5 by 1 millimeter square. 10 to the power minus 3 square. Whatever you will get the answer in terms of Newton. We have to write. Of course, 10 to the minus 6. So 10 to the power 3. This will be 45 into minus 6 plus 6. This is 15. 10 to the power 16. Or in scientific representation, 4.5 into 10 to the power 17 Newton. My problem is vector form. How to apply? This part is completely scalar form, I told. We will go for vector form. Let us go Coulomb's law in vector form. Now, let us derive this vector form properly. Let us consider a charge Q1. Which charge you want to take? Let us take plus Q1. Another charge is here, plus Q2. Separated by a distance, let the distance is R. This is the magnitude part. Why I am taking away? Just look it. Similar charges will, two positive charges repel to each other. Let us think it properly. Direction 1 to 2. So what is the direction? Let us go for some vector concepts. Let me tell you. R1, 2. Cap means direction, unit vector directions from 1 to 2. Now I will take R2, 1 cap. What is it? Direction, unit vector direction from, I will write 2 to 1. Is it okay? R1 to cap means the direction it represents 1 to 2. This direction is nothing but R1 to cap. This direction is what? 2 to 1. So I will write this as R2 1 cap. So I think you got that concept. R1 to cap, R2 1 cap. That means if I move to this direction is R2 1 cap direction. This direction is R1 to 2 directions. Now let us think. Suppose I want to write F1 2 vector. That means force acting on 1 by 2 or due to 2. Or if I'll go for book language, it is force on Q1 due to Q2. Force on Q1 due to 2. Let us derive it. What is it? On 1 due to 2. It will push it away just like this. If it is be plus minus means they will be attractive. Since it is plus plus, they will repel to each other. So force acting on 1 due to 2, it will push. So what is that this direction? This direction is force acting on 1 due to 2. This is F1 2. So what is the direction of F21? Similarly, force acting on 2 due to 1, it will be F21. This is the directions. So if I'll write F21, similarly I will write force on Q1 by Q2 or due to 2. Who is applying force? That is outside. On whom it is acting? That is inside. Let us go for mathematical part. F1 2. So what is the scalar form? K Q1 Q2 by R square. Direction. This is the magnitude part. This part represent magnitude part. So what is the direction? Force acting on 1 due to 2. This direction. So what is this direction? R21. I will write it here. R21 cap. Let us go for similarly. What is force acting on 2 due to 1? Obviously, magnitude is same. K Q1 Q2 by R square. What I told? What is this? This is the direction of F21. This is direction of F1 2. Now my question is, what is F21? This is the magnitude part. What I told just earlier. The direction is what? Force acting on 2 due to 1. It is away. This time force 1 is acting on force to 2. It is just this direction it is acting. So I have to write this is, what is this direction? R1 2. So this part represents the direction. So why we need to know? What is the importance of vector form of Coulomb's law? This is the vector form. What it represents? Let us check it here. From the figure, what I got? R1 to K, the direction and this direction just opposite to each other is minus R21 K. Like I will tell 5 km north is minus 5 km south. Similarly, I can write it. So this thing I can write. Suppose I am marking it equation 1. Suppose I am marking it equation 2. So from equation 2 I can write again. F21 vector is nothing but equal to K Q1 Q2 by R square. I can write R12 square. I can write R21 square. All are same meaning because distance is same. Only direction change. This is minus of R21 cap. So except this minus symbol, rest are equal. R21 cap, R21 cap. K, K, Q1, Q2, Q1, Q2. R square, R square. So F12 and F21. So from equation 1 and 3, what can you write? F12 is nothing but equal to minus F21. You can ask, sir, can you write this for two opposite charges? Yes, we can write. How can we write? Let us check it now. Suppose I am telling there is a charge plus Q charge. Let this is 1 plus Q1. Let this is the charge minus Q2. Let they are separated by a distance R. Let us think it. Opposite means they will attract. Positive, similar means repulsive. Opposite means they will attract. So what is the direction? Let us focus it. Force acting on 1 due to 2. It will attract. So what is this force? Force acting on 1 due to 2. So when I will think for force acting on 2 due to 1, it will also attract. 1 will attract 2 towards itself. So it will be force acting 1 due to 2. Sir, what is the direction of R12 and R12? R21, R12 is always 1 to 2. R21 is always 2 to 1. Let us go for the question. In this case, what is F12? So F12 is obviously K Q1 Q2 by R square. Direction is, let us check. Force acting on 1 due to 2. This is the direction 1 to 2. So I will write here 1 to 2 direction. If I will go for F21, K Q1 Q2 by R square. Now what is it? Force acting on 2 due to 1. It is pulling towards itself. That means this direction is 2 to 1. This direction is nothing but R21 cap. This direction is nothing but R12 cap. So 2 to 1. I think you got the idea for opposite charges how the forces act on each other. That is the Coulomb's force. Now if I'll go for permittivity or relative permittivity of a medium, what should I tell? Let us go for the concept relative permittivity. Some persons they are writing capital K, some persons they are writing epsilon R. For the time being, let us focus to epsilon R. That is ratio of epsilon to epsilon naught. That means permittivity of medium to the permittivity in air or free space or vacuum. This ratio is known as relative permittivity. Suppose two charges are in air medium. What will be the formula force? This will be equal to, I can write it, K Q1 Q2 by R square. This K is small k. Or I will write, to avoid the confusion, 1 by 4 pi. This is for air case. Free space means air case. This is epsilon naught. Q1 Q2 by R square. If I'll write for medium, this force will be equal to 1 by 4 pi epsilon Q1 Q2 by R square. Now, if I think it properly, if it is for medium, let us divide it. You can write it also epsilon naught into epsilon r also. So if I divide it properly, I want to divide force in air to force in medium case. That is equal to 1 by 4 pi epsilon naught Q1 Q2 by R square whole divided by 1 by 4 pi epsilon Q1 Q2 by R square. All these factors cancelled. 4 pi cancel. So if I'll get the answer, this is epsilon by epsilon naught is nothing but epsilon r or capital K, whatever you are telling. So the relative permittivity we are getting force in air medium to the force in medium. This is also another definition of relative permittivity, which is defined as the ratio of force between two charges separated in a distance in air medium to the force between two charges separated in a medium. So this is relative permittivity. Okay, some discussions are also there. Some examples we need to solve. Suppose I am telling, let the question is, these two forces separated in a medium whose relative permittivity is 5, for example. So what is the force acting between themselves? What is the force formula? K, Q1, Q2. In this case, I will write 1 by 4 pi epsilon Q1, Q2 by R square. And 1 by epsilon, from here epsilon and epsilon r, what will I get? Epsilon is epsilon naught into epsilon r. Let us put that value here. 4 pi epsilon naught into epsilon r q1 q2 by r square, let separated by 1 mm distance. So I will write it here. 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Epsilon r is given 5. Q1 q2, let this is 5 coulomb, this is 10 coulomb. So this is 5 into 10 is 50. 1 mm means 10 to the power minus 3 square, and after solving you will get in Newton. Now some concepts are there, we need to think it properly. Let us go for some numericals. Okay, we will solve the numericals in second part.